And we are going to discuss about nanoparticles and its application. So, through nanotechnology, we can produce various materials at nanoscale, and those materials are known as nanoparticles. And nanoparticles basically have one of its dimension in the range of 1 nanometer to 100 nanometer. So, if one of its dimension is in the range of 1 nanometer to 100 nanometer, so you can expect that there is high surface to volume ratio, and so what researchers found very interesting about nanoparticles is their size, because size can influence the physicochemical properties of the nanoparticles, like optical properties, electrical properties, and magnetic properties. Next. So coming to classification of nanoparticles, there are various bases on which we can classify nanoparticles. One of the bases can be the type of material we use in nanoparticle, like organic nanomaterial, inorganic nanomaterial, and hybrid nanomaterial. Few of the examples are carbon nanotube, metal nanoparticles, semiconductor nanoparticles. One of the bases on which we can classify is on the basis of dimension, like 1D nanoparticle, 2D nanoparticle, and 3D nanoparticle. 1D nanoparticles are like nanofilms, and 2D nanoparticles are nanorods, and 3D nanoparticles are nanotubes. So, how can we synthesize nanoparticles? There are two methods. One is physical method, and second is chemical method. Physical method is not very useful. So, coming to chemical method, chemical method has two types of method. One is top down, and other is bottom up. In top down synthesis, we break bulk material into a smaller entity, and that smaller entity is nanoparticle. And in bottom up, we join smaller atoms to make a nanoparticle. So bottom up synthesis is more useful method to produce nanoparticle, because we are joining smaller entities. So we have full control on the atoms, and there is lesser defect as compared to top-down approach, because in top-down approach we are simply breaking. So there is more wastage formation and defects also. Coming to physicochemical properties, as I earlier said, that size is the most important property of nanoparticles, which can influence different properties. So one of the properties, optical property, which is also affected by size of the nanoparticle. So how can size be influenced in nanoparticle is if we increase the gap in between the energy band gap. So this also influence the size of the nanoparticle. And other is surface plasmon resonance, which also affects the size of the nanoparticle. So which indirectly affects the optical properties and electrical properties of the nanomaterial. So in nanomaterial also there is high Young's modulus, and strength also. So now coming to the application of the nanomaterial. So now Utkarsh will proceed, and now he will talk about the application.
So I'm going to discuss about what is the effect of silver nanoparticles on Ag and Ag2 composite, and how the Ag2 composite is prepared by exposing the silver nanoparticle silver nanoparticles on the oxygen plasma using the thermal evaporation method. So here the result we obtain in this AD2 preparation is effect of silver nanoparticles on the each and every chemical bonds in AD2 composite, and this is inferred from the fact of silver nanoparticle. This is inferred from the decrease in intensity on moving toward the lower wave number. And in the application we found that the effect of this silver nanoparticle is more in the frequency range of AG2 composite, and the effect of silver nanoparticle decreases on the higher frequency wave. There are some applications. First is optoelectronics. Optoelectronics is used for the sourcing the light and detect the light and control the light. And solar cell, we can use the silver nanoparticles for storing the energy. And photochromatic optics, the silver nanoparticles in this type of devices are used to, we have specs sunglasses, in which the sunglasses get darker in the presence of sunlight, and it becomes transparent in the absence of in the sunlight. It becomes darker. In the absence of light, it becomes transparent. And so here it is how the AG2 is prepared. It is in the two steps. In first step, the thin film, the silver films are deposited on the silica glass and silica 100, and after decomposition, these films are exposed to the oxygen plasma, through which the silver film get oxidized and we get the AG2O composite. And the result, here we see that the amount of oxygen is increasing and going down in this graph. The sample D have a highest amount of oxygen, and this also we have the semiconductor devices, semiconductor properties is obtained, and the intensity is decreasing with the lower wave number. As we go toward the lower wave number, the intensity is also decreasing. And the special feature about the FTI is a Fourier transform of infrared spectroscopy. This shows the effect of silver nanoparticles on each and every chemical bond in AG2 composite, and the effect of silver nanoparticle is more in the range of frequency range of AG2 composite, and this it decreases at the higher frequency energy. And in this we can see the mu is the amount of the mu is directly proportional to the band gap, and if the band gap is increasing, the conductivity is decreasing. After the conductivity decreasing, the polarity in Ag and oxygen bond get also decreases. Here from this graph we can see that mu is directly inversely proportional to the grain size, and the amount of concentration on the particles is directly proportional to the mu. And this graph is showing the red shift and blue shift. Blue shift is shift of peak at the higher wave number with the power transfer of 100 watts, and the red shift refer to the shift of peak at the lower wave number as the power shifted to 1250 watt. And the conclusion here is effect of silver nanoparticles on the infrared spectra of silver oxygen composite, and this effect is more in the higher. This effect is more in the frequency range of silver oxygen, and this effect decreases with the higher frequency ranges. So continue.
Hello, I am going to talk about the preparation and modification of bands by using nanoparticles. So basically what we do is that Sarvan told before that we synthesize the nanoparticle of TiO2 and Zereno by using the chemical method and using green chemistry. And basically the introduction is nanocomposite application. Here there are too many applications in which this method is used, just like biomedicines and the electronics and the construction, due to the multifunctional properties like anti-corrosion and antibacterial. Basically Zereno is a very good help in the antibacterial properties, and TiO2 is used in anti-corrosive properties. And next, So basically, this is the methodology I am going to tell about how we synthesize the. First, we took a material, lemongrass, and then we cut it into small parts, and then we put using a chemical reagent, titanium 4 isotoxide, and anhydrous zinc. We put and we using a enamel paint of the brand color, and we put it together and mix it, and then we make, and then this whole experiment shows that the ZNO, the TiO2 and ZNO mixed nanoparticles end up with the antibacterial and the anti-corrosive that paint. And here is the green synthesis of nanoparticle. Same thing here also, lemongrass extract reducing agent and the clapping agent, and we synthesize. Then the characteristics. Here also the application of the nanoparticle exhibits the potential of modifying paints. Here basically it changes. So there are the 3 steps. The first, we are going to anti-corrosion test, then we move to self-cleaning test, and then antibacterial test. And in the antibacterial test, performed using the aluminium disc, coated and inhibits equal to the numerator agar. Next. Now the conclusion will discuss Rittik.
Now I would like to touch upon the topic of ZNO nanoparticles. Like you all know that zinc is a very important and crucial element for our body for various processes, cellular processes. So the deficiency of zinc can cause cancer. So how come that ZNO nanoparticles are promising for anti-cancer therapies? These are the 4 characteristics: biocompatibility, selectivity, easy synthesis, and enhanced cytotoxicity. So what is biocompatibility? Biocompatibility is nothing but when zinc ZNO particles enters the body, it can degrade very easily. That's what biocompatibility is. Then comes the selectivity. It is very selective towards cancer cells. That is meant by selectivity. Then it is very easy synthesis.